Pre-statistics. Make predictions with quadratic models, Part 2. Lesson objectives. Use an equation of a quadratic model to make estimates and predictions. Compute the x-intercept of a quadratic equation using the graphing calculator. Lesson objective. Property. Let f be a function. If k is a real number solution to the equation f of x equals 0, then the point k comma 0 is an x-intercept of the graph of the function f. Also, if k comma 0 is an x-intercept of the graph of f, then k is a solution to f of x equals 0. We will use this fact to find x-intercepts for quadratic functions. Let's start with an example. Example 2. Find the x-intercepts of the graph f of x equals x squared minus 7x plus 10. Our first step is we let f of x equal 0. So now the equation becomes 0 equals x squared minus 7x plus 10. We need to solve this equation. We can solve a quadratic equation algebraically, graphically, or numerically. Later, we'll use the quadratic formula to solve it algebraically. In this video, we will use the graphing calculator to solve it graphically and numerically. The 0 command on the calculator will also be discussed. So let's go to our graphing calculator. Our first step is to go to the y equals and type in our function x squared minus 7x plus 10. I'm going to hit zoom, number 6 for zoom standard, and we have our graph. We can see that for this example there's two x-intercepts. This looks like x is 2, 3, 4, 5, and x is 5. One way we can check, we can use trace, and we can get closer to the x-intercept and see when x is 9.1, y is close to 0, and if we scoot over, we can also see when x is a little bit more than 5, y is close to 0. Another way is if we go to the calculate, and we can use number 1 value. We put the input in here and the calculator will tell us the output. So let's see, when x is 2, what's y? I hit enter and it's saying y is 0. This shows that we have an x-intercept at 2. Okay, let's try 5. When x equals 5, enter, we get another 0. So we have our 2 x-intercepts. So this is graphically. Let's try it numerically. So if I hit second and window, which is table set, I want it to start at 0 and I want it to count by 1. Looks good. I go second graph, which is table, and I can see when x is 2, y is 0. When x is 5, y is 0. So we have just found our 2 x-intercepts numerically. So this is the easiest case where we can just take the quadratic equation, put it in our y equals, graph it. We can easily see the x-intercepts. Numerically, if we go to our table, we can identify the x-intercepts very quickly. Let's try another example. Example 3. Find the x-intercepts of the graph f of x equals 3x squared plus 9x minus 18. Our first step, we let h of x be 0 and we type in this quadratic function into y1 and we'll graph it and we'll look at the table. We have the equation entered in y1. We hit graph. We don't see the vertex or the y-intercept in the graph, but we can see an x-intercept here and an x-intercept here. So it looks like this x-intercept's between 1 and 2, and this one is between -4, -5. So let's use the 0 command. If I go second trace, number 2, 0. 0 is another name for x-intercept. So I hit 2. It's asking me for a left bound, so I'm going to do this x-intercept first. So I need to go to the left of what I believe my x-intercept is. So I hit enter. Now it wants a right bound, so I'll go to the right of the x-intercept, and again I get to see the little triangles. Now it wants a guess. I'm going to pick here, and it's returning a 0 of -4.37 rounded off. Okay, let's try our second one. We go to 0. This time we want to the left of this x-intercept. So I've got to scoot the cursor a little bit closer. Okay, hit enter. Now we want a right bound. Okay, and now a guess. I'm going to say the guess is right here. Hit enter. And now it's telling me the 0, or the x-intercept, is about 1.37. So sometimes x-intercepts are not integers. The 0 command can help us identify these x-intercepts. Let's do it numerically. So if I go second and graph, which is table, and what I want to look for is I want to look for when there is a sign change. Here we have a negative number, here we have a positive number. So that tells me that the graph crossed the x-axis. It was negative, now it's positive. So somewhere between 1 and 2 is an x-intercept. Here we have all negative numbers, and when we get to -5 we have a positive number, so it crossed the x-axis again. So now we know there's an x-intercept in between -4 and -5, and we can go to table set, tell it to start at -5. This time, instead of counting by 1, let's count by 0.1. Go back to table, and again we are looking for a sign change. And here we have a positive 0.48, here we have a negative 1.23. So now I know my x-intercepts in between -4.4 and -4.3. If I want to be more precise, go back to table set. We'll start at a -4.4, and then this time we'll count by 0.01. And as we scoot down, here is the change in the sign, and that's happened between -4.38 and -4.37. And actually this one is closer to 0 than this one. Numerically, we would say to 2 decimal places the x-intercept's -4.37. We could do the same for our second x-intercept, but I'm going to skip that for right now. And for the last example in this video, I would like to go back to the example in the first video where we had this quadratic function and we wanted to know what values of t produced a value of 39.7. So our first step is to substitute 39.7 in for f of t. Now we want to subtract 39.7 to both sides, so this quadratic equation is equal to 0. So now our quadratic function that we're interested in is 2/3 t squared minus 4/3 t plus 16. This is what we put into our graphing calculator. So we have our equation in y1. We hit graph, and we can see an x-intercept here, and we can see an x-intercept here. It appears this is -4, and this is a +6. If we go to our table, yeah, we can see when x is 6 we have a 0, so that's an x-intercept, and when x is -4 we have a 0. So we solved this equation. There are two values when t is -4 and when t is 6. And if you recall, back in the problem, t is the number of years since 2000. So t is -4 corresponds to 1996, and when t is 6, that corresponds to a year of 2006. Thanks for watching.